Hi guys, change of scenery. This is our bedroom. Yes, that is a hat on a pole that you see behind me. That's beach hat. Everybody needs a beach hat. That's where I keep mine. Um, all right. So one little nice piece of information here is that I think I finally figured out how to use headphones and a microphone, so that some of that nasty feedback that we've been getting will now be going away. It's not that I wasn't aware of it. I just couldn't figure out how to get rid of it and to make this thing work. Um, anyway, on to our topic, which is going to be um, some more looking at resistors, mixed resistors. Um, let's see, and get this up here and get this going. All right. Okay. So what we've got in this particular session is a number of those multiple choice style clicker questions. We're going to have the question slide. I'm going to ask you guys to think about it, to pause, think about it, see if you can figure out what the right answer is. And then I'll give you the right answer and a little bit of an explanation. So at this point, we'll take a look at question number one. Question number one, we've got three different resistors, 1, 2, and 3. And the question says, well, what's the first step we should take in trying to combine these resistors to figure out the total resistance if we actually had values? All right, so pause. Okay, so let's see what the right answer is. It looks like the correct answer is answer number C, that we should combine resistors 2 and 3. All right. So if we take a look at this, and you may have chosen something different, but if we take a look at this, what we're trying to do is identify simple combinations or combinations of simple series and simple parallel resistors. So if I look at 2 and 3 there, I can see that they're parallel to each other. There's no other resistors in the way. There's no additional resistors in either one of those lines or anything like that. So I can identify that that's a simple parallel combination. And as a result, I can use something like this: 1 over RA is equal to 1 over R2 plus 1 over R3 to figure out my equivalent resistance of those two resistors there. So I would plug in values, figure out what R sub A is, and then move on. Now, y'all might have a question about, well, why couldn't I just maybe combine 1 and 2 and say 1 and 2 are in series? Well, they're not actually in series. They're not in a simple series combination, because if you look, there's this split right there. And that split means that 1 and 2 aren't actually in series with each other at the moment. There's more complication that gets in the way of that. So that's why choice A or choice B isn't the right choice. And choice C is the correct one for this one. Okay. So I wanted to go through and to try and explain again what we would do here. So this is 1 over RA. Just call my resistance that I'm figuring out R sub A for lack of anything better to call it. Whoops. You guys can't see my whoops, but trust me, there was a whoops there. When I get a value for R sub A, what I'm going to do is I'm going to redraw this circuit. And now I've got R sub 1 there, and I've just replaced R2 and R3 with a single resistor, that's RA. I don't know why I'm talking to my face over here when I should be talking to the camera right there, but I'll probably continue to do it. And now, if we want to figure out our total resistance, well, those two are in series, so we're just going to use our equation for adding series resistors. All right, and that does that. Okay, now next question. So on this one, we've got 5 different resistors. The question is, well, what's our first step? So pause the video, think about it, and I'll give you the right response. Okay, it looks like the correct response here is choice D. And yeah, so if we chose either um, A or B, those are both good answers, but the best one is choice D, that we could do either one of those options listed in A or B. Um, so why could we add maybe resistor 1 and or resistor 2 together? Well, these guys are in parallel. It's a simple parallel combination. Okay. We could also look at resistor 3 and 4 and say, well, those guys right there are in series. It's a simple series combination. So either one of those would be okay to do. Now, I couldn't do adding resistor 1, 2, 3, and 4 together all in one step. That's not going to work. All right, in the next slide, I'm going to show you the steps I would take to figure out the equivalent resistance of this particular circuit if I had all my values. All right, so the choice that I would probably make is I would choose to add resistors 3 and 4 together. I think that's just the simplest approach conceptually that I can see. That just kind of makes it's the easiest on the eyes, I guess, as far as I'm concerned. You might disagree with me, that's fine. As long as you choose something that's right. So there we go. If we had numbers, we could plug those in and figure out a value for our equivalent resistance for the combination of 3 and 4 together. And what I'm going to do now is I'm going to redraw my circuit. This is R sub 5 down there, R1, R2, and RA. Well, if I look at this, these three guys right there are all in parallel with each other. So I would pull out my formula for adding up parallel resistors. In order to figure out an equivalent resistance there. And then once I had that, I would again redraw, plugging in my equivalent resistance. Oops. For those three resistors, I forgot that. There we go. I'm supposed to have a resistor there. Use your imagination. Okay. And now these two resistors are in series, so my total equivalent resistance is just going to be the sum of those two. All right. On to the next question. Okay. So in this one, it looks like what? We've got 4 resistors. And again, we're trying to figure out what's our first step in combining these resistors. So pause the video. Okay, so let's take a look and see what the right answer is. The right answer is choice A. So I'm going to combine resistors 1 and 2. The other ones would be invalid. Let's see if we look at choice B. Choice B says combine resistors 3 and 4. Well, you might think that maybe 3 and 4 are in series with one another, but they're not, because we've got that right there that's getting in the way of 3 and 4 being a simple series combination. All right, how about choice C, combine resistor 1 and 3? Well, you might say that maybe 1 and 3 are in parallel with each other. And the thing is, though, they're really not, because we've got this additional thing here that's on the line that resistor 1 is on. So we need to get that knocked out first before we think about what's on the 2 separate lines that I have, this one and that one. All right. The next one says combine resistors 2 and 3. Well, that's the same argument that I just made for choice C. All right. So let's see what approach I would take to actually, okay, I'm putting dots on the screen. Okay. Stop it. Okay, there we go. What approach would I take to actually try to start solving this? Well, the first thing I'm going to do is I'm going to redraw this circuit in a way that just maybe is a little bit more clear for me. I can redraw these circuits any way I want, just as long as the way that I redraw it is equivalent. Little sloppy. Hopefully you guys can make out the resistors that I'm trying to draw in there, R3, R1, R2. There we go. If I look at these, that's the exact same circuit as the schematic that I gave you guys. It's just redrawn so that I can see things a little bit better. 1 and 2 are in series with each other. So we'll use our equation for adding series resistors to figure out an equivalent resistance there. We will redraw the circuit, maybe over here. Okay, R3, RA, and R4. Okay, look at this, and we can say that, oh, 3 and A are in parallel with each other. This is actually the exact same circuit that we had in question 1 just a few minutes ago. And the steps are the same from there. So what do? We figure out an equivalent resistance using our parallel resistor formula. We redraw. And now we can figure out the total resistance. All right. Next one. Okay, so on this one it says we're supposed to find the equivalent resistance again, and then maybe what would the first step be? All right, so I will pause. You can pause this and answer. Let's see our answer. The correct answer here, the easiest way to approach this is to realize that resistors 2, 3, and 4 are all in parallel with each other and just combine them all in one go. Now, some of you guys might have picked maybe choice B here. Choice B is not a bad answer. It's fine. It'll get you there. It's just a slower route. Let's see if I can drag this up. I couldn't do either choice A or choice D. If I try to combine resistors 1 and 2 and say that they're in series, well, they're not, because I've got that junction there getting in the way of that idea. If I try to combine resistors 1, 2, and 5 and say that those guys are all in series, well, again, I've got junctions that are getting in the way of that idea. I can't do that. All right. So let's take a look at maybe the steps that I would take here in order to find an equivalent resistance. So all those guys are in parallel with each other, even though it looks maybe a little bit strange. We could redraw it to maybe make the picture a little more clear. But there's different options for, if I've got current. And let's grab black. If I've got current maybe coming through here, some current I, and it gets to that right there, some of that current's going to go this way, some of it's going to keep going that way. Well, then it gets to the next place where we could split off. Right there. Well, not right there, sorry. Right there, and some of it's going to go this way, some of it's going to go that way. So there's basically 3 separate options for where the current goes. There's no resistors in the way of any of those 3 options. The resistance only happen once, each one of those pathways is kind of fully chosen upon. So we can say that all these guys are in parallel. So let's let's just erase that. I don't know what happened. Let's go back to red. What? Oh, eraser. Sorry for you guys having to suffer through here while I stumble around. So to figure out my equivalent resistance of that combination, I can just do this. All right. And great. That's my formula for figuring out equivalent resistance for these guys in parallel. Okay, and once I have that, I can redraw. This is going to be R1, that's RA. This is R5. I look at that, and those are in series with each other. So I can just simply add them together using my series formula. That'll give me my answer. Right. Let's clear all. Okay. All right. One more of these things. I know you guys are thinking, when is this ever going to end? Okay. So in this question, this is slightly different. I want you guys to take a look at those choices that you have, A, B, C, and D, and figure out which one of these choices is not a good first step. All right, so pause the video. Let's see what our answer is. It's choice C. Choice C is not a good first step. Okay, great. Maybe I can see that choice C isn't a good first step because, well, I look at this and 2 and 3 are definitely in series with each other. And then we've got 4 on a completely separate line. And so that maybe hopefully just doesn't look like the best idea in the world. So let's take a look at the other choices though and make sure that those are good steps. So resistor 5 and 6 combined. Could I combine 5 and 6? Well, yeah, 5 and 6 are in parallel with each other. It's simple parallel. We could do that as a first step. Could I maybe combine resistors 4, 5, and 6? Well, that seems a little odd, but if we look closely, we'll realize that just like in the last problem, that 4, 5, and 6 are all in parallel with each other. Maybe we need to redraw it so that we can see that. So let me get a pen here and maybe we redraw this a little bit. There's my battery, resistor 1, resistor 5, resistor 6, resistor 5, resistor 4, resistor 2, resistor 3. What I have right there, what I've drawn, and forgive the sloppiness, but what I've drawn is exactly equivalent to the circuit that we're given in the problem. Why did my stylus? Oh, it's because I've got a button on my stylus that I keep accidentally depressing. All right. So what I've drawn there is exactly equivalent to the circuit that we're actually given in this problem. It's now maybe just a little bit easier to see. All right. The last choice here was, well, could I combine resistors 2 and 3 as a first step? Well, sure. Yeah, they're in series with each other. It makes sense. I could do that. All right. So one more slide here. I want to go through and show you guys the steps that I would take to figure out my equivalent resistance for this circuit if I had numbers for everything. So let's take a look. I've got resistor 2 and 3 there. They're in series with each other. I think this is the easiest thing to do, honestly, is just to figure out an equivalent resistance there. Okay, so get that equivalent resistance for those two resistors and then redraw. Do this the smart way this time. Okay, this is R1, R6, R5, R4, and RA. And now if I take a look at this one, what do I see here? I see that, well, I see that I meant to change my color. Okay, there we go. I see that all those guys are in parallel with each other. I've got 4 parallel lines. So I can figure out an equivalent resistance there. 1 over RB is, well, 1 over RA plus 1 over R4 plus 1 over R5 plus 1 over R6. All right. figure out what RB is, and then RB. Sounds like Arby's. Kind of hungry. I think I'll just end that reasoning there. Nobody's here to laugh at my jokes anyway. All right. You thought the jokes were bad in class. All right. It's probably even worse now. Look at that. 1 and 5 are definitely in series with each other. So my total resistance is going to be R1 plus R5, or R1 plus RB, excuse me, RBs. And that is my total resistance for this particular circuit. And I could go through and do all that if I had the numbers again. All right. This is the last slide. You guys may have noticed I'm not wearing glasses. Why am I not wearing glasses? Glare. All right. I'll see you soon, or won't see you soon, but yeah, hope you're doing well. Stop it. Figure out how to stop the video. Stop it. Oh, this is awful. Stop the video. In meeting. Yes.